Hello, students. So this is another video for Unit 5. We're going to talk about Lesson 4, General Form to Vertex Form. We're going to practice a skill known as completing the square. And again, I'm going to be using our notes to help guide me in the explanation for this. All right, so I'm just going to pull up that video. Here we go. It's known as completing the square. So the first thing I want you to do is recall something that we reviewed at the very beginning. Well, actually before Unit 5, Unit 3, where we reviewed factoring. So I want you to recall that x plus 3 squared is the same thing as x plus 3 times x plus 3, right? And that if you were to go and expand this, you would get x times x, which is x squared, x times positive 3, which is plus 3x. Then you would go 3 times x, which is again plus 3x. And you would go 3 times 3, which is plus 9. So you would end up with x squared plus 6x plus 9. Okay? And how you got this x squared, that was the x times x. Oops, I don't know where that little dot's from. And how you got this 6x squared was 2 times 3x. Ooh. 2 times 3x, and you got this by doing the 3 squared. Okay, so that's really important to take into consideration because that is what we're going to use. We're going to manipulate trinomials that were given to create trinomial squares, to put something that's in general form and to put it in vertex form. The benefit of this is once it's in vertex form, we can easily tell what the vertex is because it's given to us by the numbers in the P and Q position. We can tell how it's compressed or expanded / stretched because of the number in the A position. And we can solve for our values by moving things to each side. And there's also another reason why we want to learn how to complete the square, and that's because it helps us later on to understand where the quadratic formula came, because it's actually repeating these steps over and over again, which allow them to figure out this equation, which we're going to talk about much later. All right, so here we go. We have y equals x squared plus 6x plus 8. Now this is not a trinomial square, but we can manipulate something. And how we're going to do that is we're going to not write what I just wrote. We're going to add a value. We're going to subtract the same value. And when we add and subtract the same value, if we add 5 and subtract 5 from that right side, we have not changed the value of this equation. All we've done is we've manipulated it. So we want to put a value in this box that is going to help us create a trinomial square. And I conveniently used the same numbers here and here that were here and here. So when we have 6x squared, what is half of 6x? It's 3x. And look at just the coefficient of that term, 3. If we were to square 3, we would get 9. So we're going to add 9, and we're also going to subtract 9. So overall, we have not adjusted or changed the value on the right-hand side. We're just manipulating it. And that means this here is a trinomial square. So if we were to rewrite this, and this, sorry, is the leftover. So this is the trinomial square here, and this is kind of the leftover residual thing. So if we were to rewrite this, we would get x plus, and then to find out what the value is in that bracket, it's just the square root of 9. We already know it's a trinomial square because we manipulated it to be so we don't have to check it in any way. But half of 6, or the square root of 9, is 3, so that is the value that's going to go in there. So that is the same thing as all of this has been rewritten like this. And now all we have to do is deal with this leftover bit right here. -9 plus 8 is -1. And what do you see? You see a quadratic written in vertex form. Okay, so I want to pause the video here and you can try that next one. Or you can look at this and then try it again yourself. So we have y equals x squared minus 10x plus 14. So we're going to rewrite this. We want to add something, and it has to be an add. Remember, a trinomial square, that last term has to be positive because it's a perfect square. So regardless of whether this middle term is two negatives multiplying together become a positive. So this first box, we want it to be a positive, just like this box right here, okay? But we also have to subtract the same number. So that second thing we add, technically, is going to be a negative value because we plus and subtract the same thing, so that we're not actually adjusting the value of that right side, we're just manipulating it. So when we need to figure out what this magical number is, it's going to give us a trinomial square. We need to think, what's half of 10 or -10? And it's 5. So then we're going to square that. Half of 10 is 5. 5 squared is 25. If we add 25 to the right side, we also have to subtract 25 because otherwise, it's not the same thing. And we've changed it irrevocably, and it's not the same thing. So we have to add and subtract the same value. Okay. So now, here is our trinomial square. So we're going to write it as y equals, it's going to be x. Now, it's going to be a minus because this term here is a minus. So that's why it's a minus here. And then half of 10 is 5, or you can look at it as the square root of 25 is 5. They should be the same number, all right? So half of 10 should be the same number as the square root of 25. It's 5. Of course, it's squared. And now I just need to go -25 plus 14 is -11. And I have completed the square. Pause the video here and try B and D. Welcome back. So we're going to go y equals x squared minus 8x. Half of 8 is 4. 4 squared is 16, so we're going to plus 16. We also have to minus 16, and then we have to not forget that plus 1. Okay. So this, written as a trinomial square, will be x minus 4 squared. And then -16 plus 1 is going to be -15. And then the next one, y equals x squared minus 4x. I'm going to color code this a little bit. And half of -4 is -2. -2 squared is +4. But we're also going to subtract 4. So overall, we're adding 0 to that side. And minus 5. Okay. Rewriting this as a trinomial, as a square, is going to give us y equals x, and because this one was negative, it's going to be negative in here. Half of 4 or half of 4 or the square root of 4 is 2 squared, and -4 minus 5 is going to be -9. Okay, so that's how we do. The next example is when we have this little pesky number in the A position that is not a 1. So when this number in the A position right here is not a 1, not a positive 1, we have to kind of get it out of the way in order to complete the square and then put it back in again. So how to do this is you're just going to divide everything by 2. Okay? And you're just going to leave it as y over 2. and have everything else, it means divide every single other term by 2. So 2x squared divided by 2 is x squared. 4x divided by 2 is 2x. And 7 over 2, you're just going to leave as 7 over 2. Don't try to make things more difficult for yourself. Do not put that into a decimal, especially if it's a nasty irrational number where you're going to lose precision if you write it down and have to round off. Just leave it as 7 over 2, just like that. You're going to see that things are going to be okay. All right. So right now, we're going to focus on, again, completing the square for that. So we're going to rewrite it. Y over 2 equals x squared plus 2x. And then what half of 2 is 1. 1 squared is plus 1. So we're going to subtract 1. And then we're going to add that 7 over 2. I don't know why I made it purple instead of black, but that's what we did. All right. So now we're going to do exactly what we did, just kind of ignoring those 7 over 2s and that y over 2, and just focus on that part that I underlined in blue by writing it as a square as well. So it becomes x plus 1 squared. And then I'm going to leave this as minus 1 plus 7 over 2 because it's a fraction. And I actually know I'm going to get rid of that fraction with my next step. So I can't forget this is also y over 2. Okay. So at the very beginning, we divide everything by 2 to get the 2 out of the way. Now we're going to do the opposite of divide by everything by 2. We're going to multiply everything by 2 to put the 2 back into the picture. So everything is going to be multiplied by 2. Okay, so y over 2 times 2 is y equals 2x plus 1 squared. Negative 1 times 2 is negative 2, and positive 7 over 2 times 2 ends up just being positive 7, right? Because if you multiply a fraction by the same number that's on the denominator, those 2's cancel out and just leave you with what the numerator is. Okay, so now I have y equals 2x plus 1 squared. Negative 2 plus 7 is positive 5. All right, there we go. That is our vertex form. So we're going to do the same thing over here. We have a negative 5 in the A position. I don't know why I'm talking weird all of a sudden. Right. So we got to get that negative 5 out. And how we're going to get this pesky little negative 5 out of the way is that we're just going to divide everything by negative 5. We're just going to hold it over there on the left side with the y until we're ready to put it back into the right side again. Okay, so everything on the right side is divided by negative 5. So negative 5x squared divided by negative 5 is positive x squared. Negative 20x divided by negative 5 is positive 4x. Negative 30 divided by negative 5 is positive 6. And there we go. We have nothing except for a beautiful positive 1 in the A position, which means now we can complete the square. So we're going to rewrite this out, just holding that negative 5 over there so it stays out of our way for a second. All right. And we're going to add half of 4 squared. So half of 4 is 2. 2 squared is 4. We're also going to subtract 4. So overall, we're actually just adding 0 and not changing the value. Sneaky little mathematicians, aren't we? Okay, so now we're going to scroll that down. We have y over negative 5, so don't forget that's there. We're going to rewrite all of this as a square, so x plus 2 squared. And then we're going to simplify this. And I am going to simplify this time because there's no weird funky fraction. I can add negative 4 plus 6. It's going to give me plus 2. And now I'm ready to put the negative 5 back in the game, all right? It's had its time out. It can come back out to play again. So we're going to multiply everything by negative 5. And then that's going to give us y equals negative 5 x plus 2 squared. And then 2 times negative 5 is negative 10. And here we go. Right, so one question that I always get is why wasn't this multiplied by -5? And that's because it's not a separate term. This whole thing in yellow is one term, and the whole thing is multiplied by -5, which means that's why there's a -5 on the outside. So you don't multiply anything inside the bracket by -5 because by placing that -5 in front of the bracket, you're already doing that. Okay. Let's try some more examples, shall we? You can pause the video here and give these a try, and then I'm going to go over them. This one, we divide everything by 4. I'm just going to leave that as -5/4. I'm not going to put it into a decimal, just going to leave it. Right, so now half of 3 squared is the same thing as that. Okay, I'm going to leave it like that for a reason. I'm going to subtract the same thing. Okay. So you're going to get y/4 equals, to put that into a bracket, you have this number that goes in this spot is either half of 3/2 or the square root of this number here. By leaving it, instead of having to figure out what that is, I mean, we're going to anyway, we can just leave it because the square root of 3/2 squared is 3/2, or half of 3 is 3/2. Leave it as a fraction. I mean, it's 1.5, but just leave it as a fraction because fractions are your friends. Okay, guys? I'm actually going to expand this fraction right here because I'm going to end up with the same denominator as that other fraction. 3/2 squared is the same thing as 3 squared, which is 9/2 squared, which is 4, minus 5/4. And then I could do multiple. I could simplify those like terms and then multiply everything by 4, or I could multiply everything by 4 and then simplify the like terms. Really doesn't matter. I could do both steps in one if I wanted to. I'm going to do them in 2 separate steps just to show what I'm doing. I'm going to simplify those like terms first. Remember when we add fractions with the same denominator, that we just add the numerators. So if you have -9/4 and we subtract another 5/4, we have a total of -14/4. Right? And now I'm going to multiply everything by the 4 to put the 4 back in the game. That's not to the power of 4, that's multiplying it by 4. And I get y equals 4x plus 3/2 squared minus 14. All right, then now we're going to do the same thing here. Divide everything by -2, so we're going to have the -2 over here. I'm going to add 7/2 squared, which means I'm going to subtract 7/2 squared, and I have minus 12 divided by 2, which is +6. I kind of condensed 2 steps in one there. I just realized, sorry about that. All right, now I'm going to combine those into a squared term. So I'm going to get y/2 equals x plus 7/2 squared. And I'm going to expand this to 49/4 plus 6. And now I'm going to put -2 back in the game. So I'm going to multiply everything by -2. And I'm going to get y equals -2 x plus 7 over 2 squared minus, and then when you multiply a fraction by a whole number, it's just the numerator that gets multiplied by 2, and then you keep the denominator the same because it's technically times 2 over 1. So this is going to give me positive 49 times 2 divided by 4, or I can simplify it to 49 over 2. Minus 12. And that's really, I just changed 4 on the denominator to 2 times 2. And then, so it was going to be 49 over 2 times 2. And then the top was going to have a times 2 as well. So one of the 2's on the top and the bottom canceled out, leaving me with 49 over 2. Right. So that is not quite done though, because I have these lovely things here. And they're not like, they are like terms, but I need to make them have an equivalent denominator in order to add and subtract. So now I'm going to do a little bit of fraction review for you guys. So we get y equals negative 2x plus 7 over 2 squared plus. I'm going to leave 49 over 2, but I need this 12 to be over 2 as well. So technically it was over 1. Multiplied the bottom by 2 to get to be over 2, which means I have to multiply the top by 2 as well. 24 divided by 2 is the same thing as 12. And negative 24 divided by 2 is the same thing as negative 12. Okay. So now I can rewrite this. Y equals negative 2 times x plus 7 over 2 squared. If we have positive 49 over 2 and subtract 24 over 2, we're going to get a total of 25 over 2. And that is our final answer. I feel like I need to do a little segue just in case when I had the 49 over 4 and I multiplied it by 2. Okay, so that becomes 49 times 2, and that's over 1 times 4 times 1. But that's the same thing as saying 49 times 2 over 2 times 2, right? Because 4 times 1 is the same thing as 4, 4 is the same thing as 2 is 2. The same thing, if you're multiplying everything on the top and bottom, if you have the same thing on the top and bottom, they cancel out. And that's why, and that's how I got 49 over 2. Some more fraction review for you there, little segue. Now, going back, pop back over, eventually when my computer decides to do that. Here we go. Now we're going to write the following vertex forms in general form. So we have just gone from general form to vertex form, which has a lot of benefits to it. The other way is to do the other thing, which is to go from vertex form to general form. And this has some benefits to it as well. So with this one, we have to follow our order of operations, BEDMAS, and we have to do everything squared first. So here we have this being squared. We need to expand this, okay? So we get y equals x minus 3 squared is the same thing as x minus 3 times x minus 3 minus 7. We need to do all of this first before we can even factor in that minus 7. Not factor in, but include it. Include that negative 7. It's got to stay over there on its own for a bit while we sort our stuff out. Hopefully you're getting more and more comfortable with jumping straight from this straight to our end result. But I'm going to just go through and FOIL this in case you're not comfortable with that yet. So x squared, x times x is x squared, x times negative 3 is negative 3x, negative 3 times x is negative 3x, and negative 3 times negative 3 is positive 9. And of course we have this minus 7. Okay. And then we can rewrite this as x squared minus 6x plus 9. And I could have actually combined the negative 7 at that point too, but I'm just going to show that for a reason. So really, I want you to get to a place, hopefully, at some point in time, where you can go straight from this, where you can go straight from this, to this, okay? Because to get that first term, you square the first term. To get the last term, positive 9, you square the last term. And to get the middle term, you times these two terms together, x times negative 3 is negative 3x, and multiply it by 2 to get that middle term. Okay, so then we're just going to x squared equals, no, not x squared equals. Now we just got to simplify that and include that minus 7. So we have y equals x squared minus 6x. And then we just combine these like terms, plus 9 minus 7 is positive 2. All right, try the next one. The next one is the same thing, except for you've got a coefficient of negative 2. So we're going to just do this first. Okay, if you need to, write the 2 brackets out and then do the distributive method with all these beautiful, like we did over here with all these beautiful arrows. If you can though, go straight to the brackets. So at the first term squared is x squared. The last term squared is 25, it's gonna be a positive 25. X times 5 is 5x. 5x times 2 is 10x. I just realized I didn't give myself enough room to write it, so I'm just gonna, so we have x squared, so it's gonna be positive 10x. Okay. Now I have to multiply all of this by 2, not just 2, negative 2. So I'm gonna do that now. So y equals negative 2 times x squared, which is negative 2x squared. Negative 2 times positive 10x is negative 20x. And negative 2 times positive 25 is negative 50. And then we have this plus 6. Look at that little plus 6 hanging out there. All right, now all we have to do is combine our like terms. Y equals negative 2x squared minus 20x minus 50 plus 6 is negative 44. And there we go. We have just gone from vertex form to our general form. So the point of this lesson is that you should be able to go from vertex form to general form by completing the square, and you should be able to go from general form to vertex form by expanding, simplifying, and grouping like terms. I would like you to try these questions here in your online textbook. If you have any questions, please let me know. I hope that was good. All right, I hope that was helpful in explaining things to you. Take care, guys.